Hey everyone, and welcome. Today, we're plugging into one of the most incredible and yet invisible engineering marvels on the entire planet, the electrical grid. Right now, it's going through this huge revolution, turning from what was basically a network of dumb pipes into a seriously intelligent energy superhighway. So how does this thing actually work? And more importantly, what happens when you push it to its breaking point? Let's get into it. To really wrap our heads around this, we have to start with a kind of strange question. How is the power grid like a giant water system that stretches across an entire continent? I know it sounds a little weird, but trust me, this one analogy is the absolute key to understanding the magic that keeps our lights on. See, the thing is, the grid runs on this one single absolute rule. It has to be a perfect balancing act in real time. It's a system that demands perfect equilibrium every single moment of every single day. Let's break down what that really means. Okay, so first up, just picture the big power plants, coal, nuclear, hydro, as these massive water reservoirs. They're the source, right? They're the giant holding tanks where all that potential to create electricity is just sitting there, waiting to be released. Now, to get that energy from point A to point B, you've got transmission lines. These are basically the pipelines of the grid. We're talking massive, high-voltage cables that carry electricity for thousands of kilometers. It's just like those giant aqueducts that carried water from a reservoir to a city. And then you've got substations. Think of these as the all-important valves. They control the flow, they manage the pressure, or in this case, the voltage, making sure the right amount of power gets delivered safely to all of us. So you have reservoirs, pipelines, and valves. Simple enough, but here's the catch. Electricity has this one key difference that changes everything. You see, with water, you can just store it in a tank for later. Easy. But you can't really do that with electricity, not on a massive scale anyway. It has to be generated at the exact same instant that it's being used. And that brings us to the golden rule of the grid. Supply must always equal demand. Not roughly, not every hour, every single second. And you know what? We can actually measure this perfect balance in real time. It's called grid frequency, and you can think of it as the grid's heartbeat. In India, that pulse beats at 50 hertz. And to stop the whole system from collapsing, it has to stay locked in this ridiculously tiny window. If it drifts even a little, the whole network could go down. So how on earth does it stay so stable? Well, it happens in two main ways. The first is completely automatic, and it's all thanks to physics. It's kind of like this. If you have a full tank of water and you connect it to an empty one, the water just flows on its own, right? No one has to flip a switch. The grid does the same thing. Power just naturally flows from where it's being made to where it's needed. And this system, this elegant self-balancing act, worked like a charm for about 100 years. But then a whole new kind of power source showed up on the scene and created what you could call a massive renewable traffic jam, pushing this old, reliable system right to its breaking point. Think about the old grid. It was super simple, super predictable. You had a few huge power plants pushing electricity out in one direction, down a one-way street to all the consumers. But the new reality? It's a whole different ballgame. With renewables like solar and wind, power is being generated all over the place. And with things like rooftop solar, you and I can be what they call prosumers. We don't just consume power, we produce it too. That one-way street is now a chaotic, two-way superhighway. Okay, to really get a feel for just how complex this has become, let's switch our analogy. Forget about water for a second. From now on, I want you to think of the entire power grid as a massive road network. So, in the old days, you had a few big cities, or coal plants, all connected by these major highways. Traffic, the electricity, flowed in one predictable direction. But now, places like Rajasthan, with their gigantic solar farms, have turned into energy megacities almost overnight. Every single house with a solar panel on its roof is a brand new intersection. And now you've got traffic, actual power, flowing in both directions, causing these massive traffic jams on roads that were never ever designed for it. So, okay, we've got a huge problem here. The old roads just can't handle all this new, unpredictable traffic. This amazing system is now under a level of stress it's never seen before. The big question is, how do we fix it? Well, the fix is basically a two-part plan. And it's this brilliant mix of raw brute force and incredible intelligence. Part 1, you just build bigger roads. It's the physical upgrade. Part 2, you add smarts. You give the whole system a digital brain. All right, let's tackle part 1 first, the physical fix. This is all about laying down bigger, stronger, more efficient hardware, the actual wires and towers to handle all this new electrical traffic. And the rock stars of this physical fix are something called HVDC lines. That's high voltage direct current. The best way to think of these is as brand new multi-lane express highways for electricity. They're just incredibly good at moving huge amounts of power over really long distances with way fewer losses. So they're perfect for, say, getting all that solar power from a super sunny state to a dense city thousands of kilometers away. But here's the thing. Just building bigger roads isn't going to cut it. I mean, you can have a 20-lane super highway, but without traffic lights, GPS, and some kind of central control, all you've really got is organized chaos. That's why the second part of this solution is, to me, even more exciting. The grid is getting a brain. And that's really the heart of the problem. You can't just throw more copper and steel at this. The constant up and down of renewable energy demands a system that can think, that can predict, and that can react in the blink of an eye. You absolutely need smart traffic control. So, what's actually in this smart toolkit? Well, it's a whole bunch of amazing tech. We've got these incredible grid sensors called PMUs. You can think of them like a network of EKG machines hooked up to the grid, measuring its pulse more than 30 times every second. Then we have predictive AI that can forecast how much sun or wind we're going to get. And finally, we've got smart meters that create a two-way communication street to every single house. And look, the sheer scale of this digital rollout, it's just mind-blowing. Right now, India is in the process of deploying 250 million smart meters. Just stop and think about that for a second. You're turning 250 million homes into live, intelligent nodes on this massive energy network. It's incredible. So when you put it all together, the new electrical superhighways and this new digital brain, you're not just making small changes to the old system. No, you are stepping into a completely new era for energy. And this table really lays it all out, right? We're shifting from a grid with a few big centralized plants to one that's dominated by renewables spread out everywhere. We're going from a simple one-way flow of power to a complex, bidirectional, intelligent network. And we're moving from a system that needed manual human control to one that's controlled by AI and can even start to heal itself. So at the end of the day, why does any of this matter to you and me? Because this unbelievably complex dance is happening all around us all the time. Every time you charge your phone, you're tapping into this modern marvel, the world's largest synchronous machine, performing a perfect balancing act for over 1 billion people, holding steady at 50 hertz every single second of the day. And believe it or not, this massive transformation is really just getting started. The grid itself is getting smarter, for sure, but that leaves us with one last, really fascinating question to chew on. What happens when our homes, our cars, and even our appliances get just as smart? Now that is where things get really, really interesting.